All right, guys, this is solutions to some of the problems that were assigned recently. This is number 44 from Chapter 1. Use dimensional analysis to determine which of the following expression gives an area of the circle. Is it pi r squared or 2 pi r? So pi r squared or 2 pi r to give me an expression for area. Well, what is area? Well, let's say if I have an area of a rectangle, I have the height times the length or the base, and those are measurements of length, and I would have meters times meters, let's say, or feet times feet, but I would essentially end up with some type of length squared. So if I look at this pi, it doesn't have any units. And r, what is r? Well, r is the radius, and it is in units of some length, and I'll just say it's meters, and that would be squared. So the units of this particular equation would give me meter squared, centimeter squared, foot squared. It sure enough gives me area. In this situation, 2 pi has no units, and r has meters, and my units would be meters, and sure, that is not units of area. So how I would explain is that pi r squared has correct units for area. Maybe such an example, meters squared. All right, if the distance d has units of meters and time t has units of seconds, does the quantity t plus d make sense? Does this make sense? Well, what was the units of t? That was in units of seconds. And then I'm going to add the units of d, which is a meter. Does this make sense? And the answer is no. I cannot add seconds and meters together, okay? Kind of like algebra. We have to have, we can only add like terms. But what if I took d and divided it by t? Well, what are the units of d? They are meters. What is the unit of time? That is in seconds. Meters per second. That's actually how far I went over time. So I can divide different units from one another, but I cannot add them. I have to have consistency when I add, okay? The acceleration due to gravity is approximately 9.8 meters per second squared, so 9.81 meters per second squared, depending on your location. That's here on Earth, by the way. What is the acceleration due to gravity in centimeters per second squared? Well, what is my conversion factor? I know that 100 centimeters is equal to 1 meter. How do I know that? King Henry died drinking chocolate milk. Thank you. Okay, and there's my meters. And I can have my little decimal points after everything. And if I have 1 meter, I have to go 1, 2, 1, 2 to get to centimeters. So I have 1 meter equals 100 centimeters. So then I'm going to go back up to the top and take my 9.81 meters, and I'm going to put 1 meter on the bottom and 100 centimeters on top. And I am going to cancel my meters, and the only thing that's left is centimeters, so that's wonderful because that's what they asked for, and on the bottom I have seconds squared. So I get 9.81 centimeters per second squared. Oh, did you see what I just did? I forgot to do what? I forgot to actually multiply it's 981 centimeters per second squared. So, all right, so those were some solutions for the problems that I think actually might be due today. So I've helped you a little bit, and we would have actually worked together in class. So I hope that helps you. Message me if you have any questions. Thank you.